Hi, welcome to the pre-calculus lecture series. We are in the chapter 6. So here, the trig functions over the right triangles. So this is the section 6.3. We're going to take a look at the trigonometric function of angles. So when we started the chapter 6, the first video we are talking about is how to define the angle in radians and the relationship between the radians and the degrees. Then the section 6.2, we were looking for the trig function defined in the right triangles here, right? So here, for this lecture, we're going to take a look at the trig functions of the angles and in the degrees, and how do we find the trig functions and what is the relation between the one we define in the right triangles and we define the real numbers for the real functions here, real values here. All right, so that's it. Let's go ahead and start our lecture note. And this section is very, very easy section because it's basically whatever we define the trig functions in chapter 5 as in the unit circle as the real number, all the properties follow. Okay, so it will be a very easy and section to understand here because it's kind of like a repeat about the chapter 5 here. Okay. All right, so now let's go ahead and start. Okay, so the first things here, let's start the trig function of the angles here. Okay, so like in the sections, the previous section, we defined the trig function over the right angles, right triangles here. So let's take a look here. And let me see here. Let's do a better graph here. Okay, so here, okay, so let's assume this is the one. Oops, like kill my whole lines here. Okay, so let's see. This is right triangles, right? And then based on what we defined last time, let's say this is the angle theta here, right? So this is the angle theta. And then we have defined from the previous section, we said this is the hypotenuse, and this is the opposite side, and this is adjacent sides here, right? So we defined all trig functions there. So, in fact, you can put these right triangles into a coordinate system. So we'll be back to like what we defined in the chapter 5 by the, the real values here. Okay, so now what I need to move, so I'm going to move this right triangle to this way here. Okay, so the adjacent side, I'm going to put it into the x-axis here, right? So I'm kind of tutored that. So this will be this right triangle and move to the coordinate system. So make sure, of course, you put your angles here, right? Okay, so you put your angles here. So this is still my theta here, right? So you move here. So now your hypotenuse here, right? So then this one's here, we say this is my terminal point, PXY here. So let's put a terminal point PXY. So now after you put it into a coordinates, so what is this height here? This is what? This is the Y, correct? And what is this one's here? This is the axis here. So right now, this is not a unit circle, but we still can kind of put like this one's here. It's kind of like a circle. So we still can kind of put like a circle like this, right? So it's just not the unit circles here, right? So now what is a hypotenuse if you kind of instead of the unit circle, now I'm just kind of in general circle. So what is this hypotenuse? Hypotenuse will become what? Become radius. So correct, the radius of this circle. So what is radius R here will be what? Will be the Pythagorean theorem, right? So it's x squared plus y squared is equal to the r. So that's the same thing, this is how do we relate it to the trig function from the right triangle, and then you put it into the real number, the real value one, like we did in the chapter 5 here, right? So now the only thing differences here is this one, your hypotenuse become is the radius. So let's take a look at the relations here. Okay, so what is the relations here we have, right? So for the sine theta, okay, so for the sine theta in the triangle part, right, in the right triangle, we say sine is opposite over what? Over the hypotenuse. So for the real number one, the sine you can define as what? The opposite is what is y and over r here. So it's the same as the definition in the chapter 5. So if you remember, so in the chapter 5, do you remember that in the chapter 5, since we are in the unit circle, so our r in there is 1. So that's why in the chapter 5, we say sine theta is equal to 1, right? But in here, you can put any kind of the circles there. Okay, so let's take a look at what is a cosine theta. So the cosine theta here is adjacent by the right triangle, is adjacent over the hypotenuse. So the adjacent over the hypotenuse, by defining it as the real values here, is will just be x over what? X over r. So the same things here, the tangents here, it will be opposite over what? Adjacent, right? So now opposite over adjacent, so from the real numbers here, so it will be what? Y over x, right? Of course, the x cannot be equal to 0. Then you can define the 3 reciprocal. So the same one, the sine reciprocal, the cosecants, right? So will be hypotenuse over opposite. So it will be the r over y. Now, of course, y cannot be equal to 0. It's correct. Okay, so the another 2, and so the secant theta is will be what? The secant theta will be the hypotenuse here. Okay, so the secant theta here will be the hypotenuse over what? Adjacent. So that will be the r over x. Now, of course, the x cannot be equal to 0. So the same way as the cotangent theta, it will be the adjacent over opposite. So this will be the x over y. So of course, y cannot be equal to 0. So that's why I said this section is extremely easy section. So whatever you have the angles here, so when you put in the circle, is the same ways here, right? So when we try to find the value of cosine 135, tangent 390, so it's the same things here, okay? And so now for the cosine 135 here, right? So we see the 135 is equal to what? The cosine 135 we say here. Okay, so cosine 135. So basically is you are this one here is 135, right? So this is the 135 here. And then we say, just like we did before, right? So you use what? The reference angles here. So this is the 135. Then in order to do that, you use these reference angles here. So this is 180 minus 135. So this will be what? This will be, so the in here we say this is a cosine 45, right? 45 degrees, and then it's a special triangle like we learned from the previous section. So this is square root of the 2 over 2. But the cosine is on the second quadrant. So the cosine, the x has to be what? Negative, right? So these ones here will give you what? So it's a negative here, right? So now let's take a look at tangent 360 here. So tangent 360, right? So that means you go boom, 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 the whole circle, and then, right, 30 extra degrees here. So your reference angle is this one's here, it's 30, right? So this will be equal to what? This will give you is tangent, what? 30 degrees. And the 30 degrees, this is a special, what? This is a special triangle like we learned from the previous sections here. So what is this one? That will be the special triangle 30, 60, and like the 90s, right? So it will be 1 over square root of the 3, or you rationalize the denominator will be 3 over square root of the 3. Both are from the special angles here. Okay, so then the numbers, example number 2 goes showing you, even this is the degrees measurements, then the reference angle. So this is, we call it the reference angle we already used here. It's the same here. So let's see the sine 240s, right? Okay, so sine 240. Okay, so 240, so you turn. The whole thing here is 180. 240, you turn another 60 degrees here, right? So this is so this angles here, the yellow one is what? This yellow one is 240, right? So 240 degrees. And then in order to find the sine, I need to find the what? I need to find the reference angle. So what is the reference angle? Reference angle is here, right? So this green one. So what is this reference angle? Is 240 minus what? Minus 180, right? So the reference angles here is equal to the 240 minus 180, so it's 60. So the sine 240 is equal to the sine what? Here, I need to be careful. Put a negative signs here, right? So this is sine 60s, right? And then because this is on the 3rd degree, the 3rd quadrant, and is the 3rd quadrant, y is negative. So what I need to have here is negative 30s, right? So the negative 60 degrees here. So this is a 60, 30, 90 special angle. So what is the sine 60? Is the square root 3 over 2. Okay. Let's take a look at cotangent 495. So 495, okay. So in here, the whole circle is 360s, right? So the 360, then you need to do another 135 will give you the 495s here. So this yellow circles here, right? So this one is 495s here, right? So that's the 495. So the 495, now let's take a look. So like this part, so if you use 495 minus 360, so what do you have here? 135, right? So 135 is this angles here, right? So this is the red one. So what is my reference angle? My reference angle, okay, so my reference angle, remember the reference angle has to be here, right? So it's always to the x-axis, right? So it's always positive. So my reference angles here, it will be what is 180 minus 135. So it's 45 here. So the cotangent, so this one is equal to the cotangent 45. Okay, so the cotangent, we know that is the cosine 45 over sine 45, right? Okay, so 45 degrees. Let's take a look. Because right now I'm on the 2nd quadrant, so x is negative. So I know this value will be negative, but y is positive. So this one is positive, right? So the cotangent, right? So cotangent 495 will be equal to the negative cotangent 45. All right, so now let's take a look at the special angles here. Cosine 45 is what? It's like a negative square root of 2 over 2, and the sine 45 square root of 2 over 2. So what is the answer? It's a negative 1. So like we say, it doesn't matter, right? So it's always, it's a very similar, just like we did in the chapter 5. We just expanded that right now. The R is not 1 anymore. It's not a unit circle, but it doesn't matter. You can fit into any kind of the circles here, right? So the R is just by the Pythagorean theory is x squared plus y squared. All right, so everything here is follow the same like the chapter 5. And we do want to add one new thing here. This is a very kind of the very useful things, right? Is how to find the area of the triangles here. So we know we learned in the geometry, the area of the triangles here, right? So let me give you a, so if this is my triangles here, and if this is my triangles here, so this is the A, B, right? And then, so in order to find the triangle, what you need to, the area of a triangle, what you need to do, hey, you need to find the height, right? Correct? So you need to find this height here. Okay, so in order to find this height, so it's a base times, so that I know the areas here of this triangle. Everybody should know this formula is the 1/2 of the height times what? Base, right? So it's 1/2 of the height times the base here. Okay, so now let's take a look here. So the height here, right? So the height here, this is the, what is the, that means it's perpendicular from this corner to here. And now let's take a look at one beautiful formula here. So if let's say this is the theta, this is my angles here, all right? So how do I find the height, right? So the height here, so this is the adjacent side for these right triangles, right? So I know, all right, so I know that this is adjacent side for this, oh no, B is here is face the right triangles, right? So this is what, the hypotenuse. So for this triangles here, let me try to, right? So make sure we understand that. So for these triangles here, B is what? B is kind of like the hypotenuse, right? And what is the height? Height is what is opposite side of this angles, right? Okay, so now I know the sine theta. What is the sine theta? It's opposite over hypotenuse, right? So it's the height over B, right? So do a cross product. So what is my height here? Height is the B times the sine theta here, right? Okay, now the base. What is the base here? The base for this big triangle is what? Is A. So now I know my areas here is will just be 1/2. The base here is A, so it's 1/2 A times B sine what? Sine theta here, right? So very beautiful formula here. All right, so very, very beautiful formulas here. So basically, we're just telling you, if you have any triangle, right? So if I have any triangles here, right? So if this is the angle you give, then the area of this triangle will be the 1/2 this side times the sine theta, the theta in between here. Okay, it's a very handy formula. So now you probably ask, you say, how about is my triangle is not like this way? How about if I have a triangle like this, instead of acute angle, this is what my triangles looks like here, right? Okay, so if I have A's here and the B's here, so remember the angle has to be always what? Has to be between these two bases, right? So this will be my theta, right? So this will be my theta here. So remember in the high school, so we say for this type of the triangle, how do I find the height? We do the same things here. We said here, we find from here, we do this is the perpendiculars here, right? So now in here, okay, so what is this? If this angle is theta, so what is this angles here? So what is this angles here? This one I call this theta delta, right? So it will be what? It's 180 minus what? Minus theta, right? Okay, so now take a look at this little triangles here. So take a look at this triangle. I'm use different color. Okay, so now let me take a look. So let's see here. This angle is here, right? Okay, so this angle is total. Okay, so let me take a look at this little triangles here. For this triangle, where is the height? This one is the height, right? So this is the what? This is the opposite side of this theta, what? Tilt, right? And then the B, this one's here, this is the B. What is the B here? B is what? Is the hypotenuse, right? So we can do the same things here. So the area from the geometry, I know the area is 1/2 A times the height, correct? Right, so here, this is the height, right? So now the A is here, the height do the same way, the height, okay, height is the opposite over hypotenuse over B is equal to what? Is equal to the sine 180 minus theta, right? 180 minus theta here because sine is positive in the first quadrant and the second quadrant. So 180 minus theta, this will be equal to the sine theta. It's like the reference angle for that. Okay, so now you can do a cross product. So what is the height here? So it's just the same like before. So the height here will be equal to what? B times sine theta. So finally, what is my area? Area is 1/2 AB sine theta. Really beautiful, right? So we're telling you, doesn't matter if your triangle is all the angles here are acute angles, or you have an obtuse angle. It's the same things, right? So it's AB cos A times B sine theta. And the angle is suspended by both lines A and B here, right? So this is a pretty, very beautiful series here, right? Okay. Okay, so now let's take a look at the examples here. We say, hey, try to find the area of the right triangles ABCs here, all right? Okay, so you said, okay, so here I say ABCs here. So because this is the side, this is the side, and this is the side, and the angle suspended by these two sides, all right? So I know the area is the 1/2 10 times 3 times sine 120. So this is 1/30. So the 120, right? So 120 is like don't here, right? So this is 120. So what is my reference angle? It will be 180 minus 120. So it's a 60, right? That's what is in here, right? So it's a 60. And so I have this one is equal to times the sine 60. So 1/2 13, so it's a 15. So special triangle. So what is the sine 60? Square root of the 3/2, right? So my answer is 2/15 square root of the 3. And this is the centimeter square because it's the areas here. All right. So like I said, this section is a super easy section. The only new formula we have is for a given triangle, for any given triangles. Now, because we learned the trig function, we can find the area a lot easier. And everything we learned from the chapter 5 still hold in this chapter. Even, we are measuring, in the angles, and when we talk about the real value function, it's not in the unit circle anymore, doesn't matter, because the hypotenuse right now, you can use the Pythagorean theory, will be the x squared plus y squared, right? All right, that's it. Okay, so it's kind of expanded what we learned in the chapter 5 from the instead of the unit circles, right? So we kind of we kind of expanded to the any circle. Just make sure right? So just make sure your r, your radius right now is r, is the square root of x squared plus y squared. In the unit circle, your r is equal to 1 here. Okay, that's it. It's a very easy sections here, and it's nice to talk to you. And hope that we, looking forward to talk to you our next sections here. All right. Okay, have a good day. Bye.